We'll continue from first video.
Now we'll see data generation points examples. So where are mobile devices, microphones, reader scanners, science facilities, programmer software, social media, and cameras. So these are the various data generation points which are considered as big data. There is mobile devices. So we will be using several social networks through our mobile devices. So those data is being generated and stored in large volumes of data. Next, microphones, some audio recording audio players or video players, those record some audio data is also generated from this one. Next, readers and scanners, that is like QR scanners or some scanners, they are also generate data. And then science facilities where some researches are conducted, those they update the data and that is also stored. And then programs are software. So some softwares, like for example online shopping softwares, so they also generate large volumes of data which is categorized as big data. And then the social media. So currently this is the big area where the data is being generated in large volumes in a daily basis. And then cameras, that is CC cameras installed in sensitive areas, they are also continuously generating streaming data. So these are some data generation points. Like here, see, big data, a growing torrent. $600 to buy a disk drive that can store all of the world's music. So that is how much large amounts of data is available, you can assume. Next, 5 billion mobile phones is used in 2010. 30 billion places of content shared on Facebook every month. 40% projected growth in global data generated per year. Then 5% growth in global IT spending. Then 235 terabytes data collected by the US Library of Congress only by April 2011. And then 15 out of 17 sectors in the United States have more data stored per company than the US Library of Congress. So this is the intensity of the big data that is being generated worldwide, right? Next, big data analytics. So what generally big data analytics means? So it is simply examining large amount of data. That is the data that is being generated from several sources, like we have discussed earlier. Analyzing all this data or examining is nothing but big data analytics. So why do we do this? To get appropriate information from large volumes of data. Then what we can extract, identification of hidden patterns or unknown correlations. So these can all be extracted from big data analytics. Why? This is for building competitive advantage the companies can achieve from. Then this helps, analytics helps better business decisions for implementing strategic and operational methods. Then effective marketing, that is you can directly target the exact customer base, and then you can measure the customer satisfaction and you can keep on generating revenue. So using big data analytics, these are all the benefits that a business can arrive to. How big data impacts on IT? So big data is a troublesome force presenting opportunities with challenges to IT organizations. Why means as the data is continuously growing and it becomes a quite tough task to maintain such large volumes of data in small organizations. So that becomes challenges for such IT organizations. So as per the data available by 2015, 4.4 million IT jobs in big data, 1.9 million is in US itself. So big data has generated such volumes of jobs in IT sector. And India will require a minimum of 1 lakh data scientists in the next couple of years, in addition to data analysts, data managers, to support the big data space. So this big data is directly and indirectly improving the manpower requirements to maintain it. several tools that help organize big data. So first one is the NoSQL, or we can call it as NoSQL. So a database such as MongoDB, CouchDB, Cassandra, Redis, Bigtable, HBase, Hypertable, Walmart, React, Zookeeper. So these are some NoSQL databases that can be used to organize the big data that is generated. And then storing is a part. So this is the storing section, and then this is the processing section. This is the processing section. So the first one foremost is MapReduce. So the MapReduce is a program in a Hadoop which performs analysis of the data, or you can simply call it as processing the big data. So that is a part of Hadoop, and there are several other tools in Hadoop. We will call it as a Hadoop ecosystem. Some of them is Hive, Pig, Cascading, Cascalog, Emerjob, Caffeine, S4, Mapper, Akinu, Flume, Kafka, Azkaban, Uzi, and Greenplum. So these are used for processing the big data. Next also storage. So we can use several available methods for storing the large volumes of data. S3 is from Amazon. S3 simple storage service, and the HDFS or Hadoop distributed file system is a storage system supported by Hadoop. It is storing data in a distributed fashion, and hence we call it as Hadoop distributed file system. Next we need processing server capabilities, that is EC2, again from Amazon. It's a Elastic Cloud that is supported by Amazon. Next, Google App Engine from Google, Elastic, Beanstalk, and Heroku that are from other small companies which help processing the big data. Next, how we process? So using R language, Yahoo Pipes, Mechanical Turk, Sol and Lucene, Elasticsearch, Datameter, Big Sheets, and Tinkerpop. So these are the tools again help processing the big data. So using these tools, we can store, process the big data. Next, source of big data. As we seen earlier, these are some other description from where we're getting the data. Social networking site, simply called as shortly SNS, which comprises of Facebook, Google, LinkedIn. So these are some top social networking sites which generate huge amount of data on a day-to-day basis, as they have billions of users worldwide. So daily it keeps generating large volumes of data like Facebook, Google, and LinkedIn. Google means Google search. Next, e-commerce sites. So sites like Amazon, Flipkart, Alibaba generates huge amount of logs from which users buying trends can be traced. So these are the these help business improvement, because it helps you analyzing the customer patterns and you can take a decision to target the specific customers to improve the business. Next, weather stations. All the weather station satellite gives very huge data which are stored and manipulated to forecast weather. So that is, using the previous weather patterns, you can predict the upcoming weather situations in a specific location. Next, telecom companies. Telecom giants like Airtel, Vodafone study the user trends and accordingly publish their plans, and for this they store the data of its millions users. So like telecom companies like Airtel, Vodafone, and other providers, they'll keep eye on the customer behavior and their strategies. So based on those strategies, they'll prepare the new plans which helps them to generate more revenue. And then share markets. Like a stock exchange across the world generates huge amount of data through its daily transactions. This also helps several companies to understand what the customer is thinking about their company. Okay, so these are some sources of big data, and we have seen in reviews of big data: velocity, the data rate at which it is being generated, and variety, the different types of data that is being generated, and volume, the amount of data which we deal with is a large size that is considered in petabytes. So we'll see a small statistic here. 1 petabyte is equal to 1024 TB, so nearly storing 7 lakhs of HD movies. As per analysis of 2021, for every 1 hour, 300 hours of YouTube videos are uploaded into YouTube site. In Twitter account, 500 millions of tweets are posted per day. Nowadays, data must be either in audio, video, images, and text formats. So the text formats may be again some different formats. So most of the probably the generated data is being in multimedia format only. So this is generating large volumes of data, right? So what are the issues? Huge amount of unstructured data which needs to be stored, processed, and analyzed. So this is the major issue we have with big data. So and the solution is storage. The huge amount of data, example Hadoop. Hadoop uses HDFS. As I said earlier, HDFS stands for Hadoop Distributed File System, which uses commodity hardware to form clusters and store data in a distributed fashion. It works on write once and read many times principle. So that once written can be read for any number of times. So the major focus is HDFS. So it uses the commodity hardware. So commodity hardware means the normal hardware that we can use for a daily purpose. So forming a cluster with such sort of commodity hardware, you can store large volumes of data in a HDFS format. Next, how you process the data. MapReduce paradigm is applied to data distributed over network to find the required output. So as we said earlier, cluster formed with commodity hardware like system 1, system 2, system 3 and so on. The data is being distributed in all these systems. So this MapReduce works like linking to each and every system where the data is being stored. So it processes the program to the systems in the cluster and gets output from that systems. So this is as simple. Complete data will not keep moving here and there. Only the program corresponding to the application will be transferred from server to all the clients in the cluster. Next, analyze. Peak, Hive can be used to analyze the data which is part of Hadoop ecosystem. Is the data stored in HDFS can be accessed by Peak and Hive to perform some analysis on the data. Next, cost. Hadoop is open source, so the cost is no more an issue. That is, as concerned with the software tool, that is Hadoop, we need not to pay any amount for any provider. Only thing is we need to focus on the hardware cost. Okay. Several modules that are available in Hadoop. HDFS, the primary one, that is a storage system, Hadoop distributed file system, where the data is being stored. So Google at the beginning published its paper called as Google File System GFS, and on that basis of the HDFS has been developed. It said that the files will be broken into blocks and stored in nodes over the distributed architecture. Next thing, Yarn. Yet another resource negotiator is used for job scheduling and managing the cluster in Hadoop system. And another module is MapReduce. This is a framework which helps Java programs to do the parallel computation and data using key value pair. So in MapReduce, the main focus is on key and value. So this is a pair which is being generated using the MapReduce program. The map task takes input data and converts it into a data set which can be computed in key value pair. The output of map task is consumed by reduce task, and then the output of the reducer gives the desired result. So this is how MapReduce works. Then Hadoop common. These Java libraries are used to start Hadoop and are used by Hadoop modules. That is, starting a Hadoop server or stopping a Hadoop server. All these services are maintained by the Hadoop common libraries. We'll see the history of Hadoop. Hadoop was started by Doc Cutting and Mike Caffarella in 2002. Its origin was the Google file system paper published by Google. See, so in 2002, first one is Apache Nutch, which was started in 2002. Later, Google published Google file system paper. Next, 2004, Google released a paper on MapReduce, and in 2005, Nutch distributed file system was introduced. In 2006, Hadoop was introduced along with HDFS. So this is the starting point for Hadoop. Then in 2007, Yahoo runs 2 clusters of 1000 machines, and then in 2013, Hadoop 2 version was released, and 2017, Hadoop 3 version was released. This is the brief history of Hadoop. Advantages. So what are the advantages of Hadoop? So fast. In HDFS, the data distributed over the cluster and are mapped, which helps in faster retrieval. Even the tools to process the data are often on the same servers, thus reducing the processing time. It is able to process terabytes of data in minutes and petabytes in just hours. So this is the fast with which Hadoop can process the data. Scalable. Hadoop cluster can be extended by just adding nodes in the cluster. So you can keep on adding systems to the existing cluster, and it automatically improves its scalability. Next, cost effective. Hadoop is open source and uses commodity hardware to store data, so it really cost effective as compared to traditional relational database management system. So for traditional RDBMS systems, you have to use high-end systems to store and process the data, but whereas Hadoop is concerned, it is using only commodity hardware with low cost to form a cluster and thus can operate your data. Next, resilient to failure. HDFS has a property with which it can replicate data over the network. So if one node is down or some other network failure happens, then Hadoop takes the other copy of data and use it. So normally our data replicated thrice, but the replication factor is configurable. So by default, it takes 3 copies of data stored in different locations, but it is again customizable. So you can configure whatever the copies you need using the configuration system. Now this is the Hadoop architecture. See, master is the server and the slave, the client. So there are 2 layers. One is MapReduce layer and HDFS layer. So this is a layer where the data is stored. This is a layer where data will be processed. So we'll have a task tracker in the MapReduce layer, which creates a job tracker, and the job tracker is again connected with a task tracker in the slave. So a master can also task tracker and job tracker. Similarly, the client will have a task tracker. So whenever a MapReduce program runs, a job tracker initiates itself and generates a number of task trackers. On the HDFS side, name node is, we'll call it as a server. So name node is connected to several data nodes and whatever the requests coming from data node will be processed by the name node. So this is the architecture how storage and processing can be done in Hadoop system. We'll see some more details about Hadoop distributed file system. This architecture consists of a single name node which performs the role of a master and multiple data nodes that perform the role of slave. So in the HDFS system, we will have name node which acts as a server, and this will be only one in quantity. Data nodes are simply called as clients. There can be n number. So based on the cluster size, you can have n number of data nodes. Okay. Both name node and data node are capable enough to run on commodity machines. So normal traditional hardware system can be used in the Hadoop system, and these name node and data node softwares are capable to run on these commodity machines. The Java language is used to develop HDFS, so any machine that supports Java language can easily run the name node and data node software. So this is the name node which we will call it as a server. So this is the name node which contains some information. It is file name, file permissions, block IDs, block locations, and number of replicas. See, whenever a client requests some data, it will be forwarded to name node which has the metadata of the data available in the HDFS system. What it maintains, and apart from that, we'll have a secondary name node. So whenever a primary name node fails, we have an option of secondary name node which can be up and running when the name node fails. So it continuously keeps on sending data, FS file system image, and whatever edits has been done on the file, and that will be stored in secondary name node. So when it fails, it takes FS image, and the secondary name node acts as a primary name node. So these are several data nodes that are available in the cluster connected to that particular name node. So individual data blocks is being stored in each data node. So these are the blocks of data that is being stored in each and every data node. So when the client receives a request, name node processes the request, and wherever the data is available, that link will be created to the client machine to access the data. So this is how a name node works. Next, name node and data node. So this is a name node, will cast master, which works based on resource manager. So this is responsible for maintaining all the resources in the HDFS cluster. So we'll have slave 1, 2, and 3 here. It's called as data node, which has an internal node manager which controls the node manager of that particular data node. And in each slave, MapReduce programs will be there, and they will process the data based on the client request. Name node. It is a single master server exists in the HDFS cluster. As it is a single node, it may become the reason of single point of failure, but we have several approaches which can be overcome to avoid this issue. It manages the file system namespace by executing an operation like the opening, renaming, and closing the files, and it simplifies the architecture of the system. And then coming to data node, the HDFS cluster can contain multiple data nodes. Each data node contains multiple data blocks. These data blocks are used to store the real data. It is the responsibility of data node to read and write requests from the file system's clients. It performs blocks creation, deletion, and replication upon instructions from the name node. So these are some roles available in HDFS. The job tracker. The role of job tracker is to accept the MapReduce jobs from client and process the data by using name node. In response, name node provides metadata to job tracker, like metadata files information and the number of data nodes information, location of data which is needed. Next, task tracker. It works as a slave node for the job tracker. So that here the job tracker will be a master program and the task tracker will be a client program. It receives task and code from job tracker and applies that code on the file available in that particular data node. This process can also be called as a mapper. So it is a part of MapReduce program. So map task is carried out by the task tracker. Big data is different from traditional databases. We'll see why it is. While traditional data is based on a centralized database architecture, big data uses a distributed architecture. So the traditional systems run on centralized system, whereas big data uses a distributed architecture. Computation is distributed among several computers in a network. This makes big data far more scalable than traditional data, in addition to delivering better performance and cost benefits. In 2014, Data Science Central Kickborn has defined big data in 10 ways. The volume, variety, velocity, veracity, validity, value, variability, venue, vocabulary, and vagueness. So it is from Kirkborn. So comparison between traditional data and big data. In traditional data, most of the time we'll see the structured data, but whereas in big data we'll see unstructured and semi-structured data. So the size of data is very small. As compared to big data, the size is more than the traditional data size. In traditional data, the data is centralized, but whereas coming to big data, it is distributed. It is easy to work or manipulate. It is difficult to handle the data. Normal system configuration is sufficient to process traditional data, but whereas coming to big data, high configuration system is required to process the data. A traditional database tool is enough for processing the traditional data, but whereas coming to big data, we need some special kind of tools. Normal functions are enough to manipulate the data available in traditional database systems, but whereas coming to big data, it needs special kind of functions to manipulate the data. So we'll see some more thing here. Some parameters, structure of data, traditional data, structures defined, but whereas in big data, there will be mixture of both structured, semi-structured and unstructured data. Data volume based on business volumes and extent of organization, digitization, the data size depends. But whereas in big data, very high, even in petabytes and more. Variety of data sources. Data source from only database systems which are connected to the system. But whereas big data, it comes from various sources such as business information systems, text, emails, documents, weblogs, sensors, RFID data, etc. and even social networking sites data also. Velocity, low to moderate based on volume of business, but here big data, the data is being generated in at a high rate. It's a high velocity rate. Flow, the data flow is fixed, but whereas in big data, continuous round the clock, the accumulation data will be running. Structured data in traditional, but whereas coming in big data, it is structured, semi-structured and unstructured, combination of several types of data. Source of data, organizational data, trading partners data, organizational data, RFID, sensor data, Google searches, social media like Facebook, Twitter, and WhatsApp, etc. Whereas coming to analytics, provide historical view status reports only in traditional database systems, but whereas coming to big data, real time direct feedback from the consumer, sentiment analysis, and opinions can be retrieved using big data. Functions: advises senior executives on internal business decisions, focus on analyzing data for business. When big data, customer facing functions get direct market feedback, which can be used for planning, marketing strategies, other plannings, etc. So this is again the history of Hadoop, which I have seen earlier. We'll see some comparison tools used for analyzing big data. So these are several tools. First we'll see Hadoop. Hadoop is a non-relational database system. It's a open source and cloud-based platform. Advantage: stores data with any structures such as weblogs also. Limitations is lacks technical support and security. As it is an open source system, we may not get a complete technical support to the tool. Next, MapReduce tool. It is also works at a non-relational database. It is also again open source and cloud platform. Works with will semi-structured data and unstructured data such as visual and audio data. So this is the advantage from MapReduce. It lacks indexing capabilities of modern database systems. Only limitation for MapReduce is it lacks the indexing capabilities. Next, Google BigQuery. This is a column database apart different from any other databases. It is also open source and cloud-based platform. Allows data to be replicated across diverse data centers. That is, it can store the data in different data center locations, even differed by regions also. It does not support indexes. And then Microsoft Windows Azure. It is a relational database system. It is a public cloud-based platform. Advantages are allows users to make relational queries against structured, semi-structured, and unstructured files also. The size of the database is limited. It cannot handle huge databases. So these are some important tools that are more focused when you work with Hadoop. So for this we call it as Hadoop ecosystem. Hadoop ecosystem is neither a programming language nor a service. It is a platform or framework which solves big data problems. You can consider it as a suite which encompasses a number of services like ingesting, storing, analyzing, and maintaining the data inside that Hadoop system. So below are the Hadoop components that together form a Hadoop system. We'll see one by one. HDFS, we already have studied about this. This is the Hadoop distributed file system. Yarn, yet another resource navigator. MapReduce for data processing using programming. Spark, in-memory data processing. Pig and Hive, data processing services using query-like input. HBase, it's a NoSQL database. Mahout, Spark, mlib are used for machine learning operations. Apache Drill, there is a SQL type structure that can be used with Hadoop system. Zookeeper is managing the cluster. That's a you can manage the cluster in Hadoop using the Zookeeper ecosystem. Woozy, it is for scheduling jobs to run in the Hadoop file system. Flume and Scope, these are data ingesting services. Solar and Lucene are used for searching and indexing the data. Ambari, this is the provision, monitor, and maintain the cluster. So that is, you can add or remove systems into the cluster. So these are called as Hadoop ecosystem. So this is a diagrammatic representation where we can see several ecosystem parts. HDFS, Yarn, Apache Ambari, that's a Zookeeper, HBase, Woozy for scheduling, Salt and Lucene for searching and indexing, Pig for scripting, Mahout and Spark mlib for machine learning operations, Hive and Drill for analytical SQL and Hadoop, MapReduce for processing using different languages, Spark in-memory data flow engine, Kafka and Stum for streaming, and Flume and Scoop. So these are the part of Hadoop ecosystem. These are some applications where big data or Hadoop system can be used. Transportation, advertising and marketing, banking and financial services, government sector, media and entertainment, meteorology, healthcare, cybersecurity, and education. These are all the application areas of big data. So when you download a Hadoop package, this generally consists of file system and OS level abstractions, a MapReduce engine, either MapReduce or Yarn, the HDFS, the Hadoop distributed file system, Java archive files, scripts needed to start, stop and restart Hadoop system, source code, documentation, and a contribution section. So these are the contents of a Hadoop community package. Logic.